thousands of miles will be killed. You're talking here first of the blast wave, of the tsunami. You're talking about the enormous heat. Fires all around the globe. And then darkness.
For millions of years, enormous objects from space have slammed into Earth with disastrous results. One impact in the waters off the Yucatan Peninsula is blamed for the extinction of the dinosaurs 65 million years ago. But this wasn't the first mass extinction on Earth, and it probably won't be the last.
And it wasn't the biggest mass extinction event of all time, because that one was the Permian extinction, in which 95% of the species in the oceans died and about 80% of those on land. So radical extinction events have happened.
Some scientists believe these periods of death and destruction happen like clockwork.
Some paleontologists found a very strange pattern. What they found were the great extinctions, such as the ones that killed the dinosaurs, but others too, didn't happen at random times, but seemed to occur on a regular time schedule. That was very strange. They were disappearing every 26 million years. It was begging for an explanation.
Astrophysicist Richard Muller believes the explanation for this periodic destruction is a dim red dwarf star lurking on the edge of the solar system. A star that he fittingly calls Nemesis. According to his theory, Nemesis is an undiscovered companion star to our own sun. It travels between 1 and 3 light years from the center of the solar system on an elongated elliptical orbit. As Nemesis makes its closest approach to the sun every 26 million years, its orbit takes it right through the Oort cloud, a collection of an estimated trillion comets surrounding our solar system. That's when the order of the solar system turns especially chaotic.
When that happens, Nemesis gets close to the comets and perturbs their orbit.
According to Muller's theory, the gravitational disruption caused by this small, innocuous star causes long, undisturbed comets to break away from their orbits in the Oort cloud. Pulled towards the sun by its gravity, 1 billion comets are sent careening toward the inner solar system. A handful inevitably cross paths with the Earth, resulting in massive impacts and mass extinctions. The claim that our sun has an undiscovered companion Death Star is controversial. Most scientists believe that the sun is a solitary star with no companions. But in the universe, binary or even triplet stars grouped together by gravity are the norm.
The majority of stars in our galaxy are parts of either binary or triple stars. And so the idea that the sun conceivably could be part of a binary isn't crazy from that point of view at all. It's an interesting question.
Even if the sun could conceivably have a binary companion, astronomers have never observed a binary system in which the pair of stars are as far apart as Muller claims our sun and Nemesis would be. Muller needed proof that Nemesis was real. In 1997, a NASA mission began that had the potential to shed light on the mystery. The 2-micron all-sky survey, or 2MASS, used twin infrared telescopes to scour the universe for previously unknown stars. 2MASS specialized in hard-to-find bodies in and near our galaxy, and to date has produced over 2 million images. If Nemesis was out there, 2MASS should have spotted it. But the survey never detected anything fitting the description of Muller's Death Star.
We've looked real hard for Death Star, for Nemesis, and we can't find it anywhere.
But Muller isn't surprised 2MASS didn't find his Nemesis.
The reason is, at a distance of about 1 light year, which is the distance it would have in order to have a 26 million year orbit, its motion is very little. And so it would have been missed by the standard surveys that look for nearby stars.
Another possibility is that Nemesis may actually be a brown dwarf. These failed stars are much smaller than red dwarfs. And with a highly elliptical orbit, a brown dwarf would remain far from Earth most of the time and out of the watchful eye of astronomers. If that's the case, Nemesis could have easily slipped under the 2MASS radar. Richard Muller vows to continue looking and plans yet another, more detailed study. He believes it's only a matter of time before Nemesis is found.
There are lots of stars out there. There are millions of them. But when you find a needle in a haystack, you can look at it and say, well, that's not hay. Similarly with this, when we find Nemesis, we'll measure the orbit and we'll prove that it's Nemesis.
Of all the unexplained mysteries in our universe, perhaps the most tantalizing and controversial is whether it's possible to travel through time.
Can we really travel back into the past? Can we really alter our destiny? It is one of the greatest questions.
In 1955, Ron Mallett was only 10 years old when his father died of a heart attack. Grief-stricken, young Mallett yearned for a way he could see his father again and perhaps save his life.
About a year after he died, I came across H.G. Wells's book, The Time Machine, and that is what saved me, because I thought, if I could build a time machine, as H.G. Wells talked about, then I could go back into the past and try to save his life and see him again. And so I became obsessed with the notion of trying to build a time machine.
Gentlemen, I am talking about traveling through time.
The Time Machine was a work of fiction, but Mallett soon discovered there was science to support the mysterious notion of time travel. And the source was none other than Albert Einstein. Einstein theorized that space and time were linked, so that one could imagine space-time as a sort of fabric or sheet. With his general theory of relativity, Einstein showed that a massive object, like a planet, a star, or black hole, actually warps the fabric of space and time. In fact, Einstein believed that gravity, the force that binds us to the Earth and keeps the Earth in orbit around the Sun, is really just an effect of this warping. For Mallett, this mind and universe-bending idea has far-reaching implications. Because if you could generate enough gravity to twist time into a loop, perhaps you could create a pathway for moving backwards and forwards through time. Einstein's theories fueled Ron Mallett's quest to learn how to build his own time machine. But time travel wasn't a subject that could be studied by serious scientists out in the open.
As a matter of fact, I used the cover story that worked for me. I studied black holes because black holes allowed me to understand how Einstein's theory affected time, and it was a crazy idea, but it was considered legitimate crazy. So I built my career on studying that and being able to use Einstein's general theory of relativity.
Black holes, the massive remnants of collapsed stars, have an almost unmatched gravitational power to distort space and time, which is exactly what Mallett wanted to do. But how could he create in the laboratory something jam-packed with enough matter to actually warp space-time? For inspiration, Mallett turned again to Einstein and his most famous equation, E equals mc squared, which showed that matter and energy are just different forms of the same thing. So following Einstein's theory, light, which is energy, should be able to warp space and time just like a massive object does.
We're used to the notion that gravity is created by matter. But it turns out that in Einstein's theory, light can create gravity. And that is what my work is based on. In other words, if gravity can affect time and light can create gravity, then light can affect time.
Mallett has built a model to demonstrate his concept, that a circulating laser beam can create a tunnel of light that twists space and time.
It has 4 intersecting laser beams. The region within that column of light would represent the region in which space is being twisted. And eventually, time would also get twisted by this column of light. And this would allow us to travel back into the past.
The first time traveler will have to be something much smaller than a human being, a subatomic particle like a neutron.
What we're trying to do is not human beings, but to try to send subatomic particles of information to past. And that is a huge leap in itself, because imagine if we can send information back into the past that could tell us about future disasters and be able to avert those disasters. We can understand how circulating light beam can twist space and time by a simple analogy with a cup of coffee. If we think of the coffee and the cup as being like empty space, and we think of the spoon as being like a circulating light beam, then you can see what happens to the coffee as I stir it. The coffee swirls around. Well, that's what the circulating light beam is doing to empty space. And we can see the effect of this in case of the coffee by putting in a coffee bean. As I swirl it around, the coffee bean gets swirled around. In the case of the laser, as the beam is circulating, we put a subatomic particle called a neutron in. And as we stir the space around, the neutron will get swirled around, just like the coffee bean. Now, remember, in Einstein's theory, space and time are connected, so that swirling of space will cause the straight line of time to be swirled into a loop. And along that loop in time, we can go from the past to the present to the future, and then back into the past.
Science fiction has depicted time machines as allowing unrestrained travel forward and backwards in time. But Mallett cautions that a time traveler could only journey back as far as the moment that the time machine was first turned on.
In other words, if I turn the device on today and I leave it on for 100 years, then someone 100 years from now could travel back 75 years, 50 years, 25 years, all the way back to the moment I turned the device on. But they can't travel earlier than that because the device didn't exist earlier than that. And it's the device that's creating the effect. So there's nothing for the time travel to materialize into.
This limitation means that Mallet's time machine could never give him the capability to travel back to 1955 to save his father's life. To do that would take some technology from out of this world. Theoretically, an advanced alien civilization might have a time machine that was switched on thousands of years ago.
We may be able to use their time travel to go back to visit our ancient past, because if they have developed time travel, let's say 10,000 years ago, it would still have the same limitation. But once we encounter them, we could use it, and perhaps someday we may be able to visit ancient Egypt and ancient Rome.
For now, Mallet is focused on getting his time machine built. A project that will require $250,000 in startup costs alone. Money is just one obstacle facing any physicist daring to dabble in time travel. There are also certain paradoxes that many believe make time travel impossible, like the infamous grandfather paradox. Imagine you go back in time and kill your own grandfather before he meets your grandmother. Therefore, you never would have been born, and therefore couldn't have gone back in time in the first place.
And then a loop is set up of possible, impossible, happened, it didn't happen.
But Mallet believes recent advances in theoretical physics suggest that these paradoxes aren't a problem at all. Many physicists now believe in the far-out notion that our universe is just one of many parallel universes. So that when you go back in time, you might actually be entering a parallel universe in which you can alter events without affecting the universe you came from.
We believe that the river of time can have whirlpools by which you may be able to go back and meet your parents before you're born. Or perhaps even fork into two rivers by which you can actually alter the past to create an alternate universe. These are all theories that are at the very forefront of modern physics today.
Mallet believes we may be as little as a century away from time travel by humans. Still too late for him to travel back in time to save his father.
Your name? Rocky.
Rocky. Nice to meet you.
Okay, thank you very much. Remember what's happening to space, it's swirling around.
But his personal loss has opened a door for a new world for future generations.
I developed the basic equations for this.
It has led to my being able to share something with the world that I would never have been able to share before. And I feel that that is actually a fitting memorial to my father, that I've been able to do that. I feel very good about that.
As the universe was first forming, scientists believe it was comprised of more than just the regular matter that now makes up everything around us. They believe it had an almost equal amount of antimatter, matter's elusive evil twin.
If you go back to the very early universe, it turns out that it was made of matter and antimatter. It turns out that every particle has an antiparticle. And it sounds kind of crazy, but it's real. It's sort of sci-fi, antimatter.
But what is this mysterious antimatter, and where did all of it go?
Antimatter is exactly like matter. The difference between it is the fact that it has completely different charge associated with it.
Regular matter is made of atoms, which in turn are made of subatomic particles, like negatively charged electrons and positively charged protons. Antimatter are the opposite of these particles. They have the same mass, but the opposite electrical charge.
Proton's a positively charged particle, that's the nucleus of the atom. The anti-proton would be a negatively charged proton that has exactly the same mass.
In our universe, opposites attract, and particles and antiparticles are pulled together. One would think this is a relationship made for the heavens. But every time matter comes in contact with antimatter, the outcome is the same. They annihilate each other. Imagine two spaceships hurtling through space on a collision course. One is made of regular matter. The other is an antimatter craft, built by an alien civilization. The impact would be spectacular, and there would be no wreckage left behind for cosmic crash investigators to examine.
The matter and the antimatter disappear. Poof, they're gone. But the energy doesn't disappear. The energy re-emerges in the form of two very energetic gamma rays, photons. And the amount of energy locked up in a tiny amount of mass is quite astonishing.
If you take matter and antimatter and combine it, it is explosive. And in fact, it is one of the greatest sources of energy in the universe, the collision of matter and antimatter. So if I were you, I would not put antimatter in your pocket if you know it's good for you.
Volatile as antimatter is when it meets matter, there's a tremendous energy potential if we knew how to harness it.
So to get an idea how much energy is locked up in matter, if you imagine for a minute that these two piles of sand that one is matter and one is antimatter, and you let them come together, they would annihilate and produce energy. How much energy? Enough energy to power all of California for a week, just in those two piles of sand.
The biggest mystery surrounding antimatter is this. If there were nearly equal amounts of matter and antimatter in the early universe, then where is all the antimatter now?
One of the great mysteries of the universe is what happened to our evil twin, antimatter. Everywhere we look in the heavens, we see ordinary matter. We don't see antimatter. There's only a small amount of antimatter coming out of the center of the Milky Way galaxy.
Why this universe appears to be made entirely of matter and there isn't much antimatter to be seen out there is a mystery. I don't think it'll ever be explained anyway, but the mind hunts for an explanation.
One possibility is that perhaps there was a slightly higher percentage of matter than antimatter in the early universe. So as the particles and antiparticles collided in a war of annihilation, that small percentage of matter survived. The last living veterans of our most ancient battlefield.
For every billion antiprotons, you need 1,000,001 protons. Then the billion all annihilate, and you're left with that one proton.
And the leftover is us. We are the residue. We are the leftover of this titanic blast of energy released by the collision of matter and antimatter at the instant of time. our most advanced theories cannot explain why there was this asymmetry between matter and antimatter. But thank God it exists. Otherwise, we wouldn't be here.
But even though matter prevailed to make up everything we see around us, could there be distant galaxies or regions of space where antimatter still reigns supreme?
It may be that there are entire galaxies that are just 99.9% antimatter, just like this one is matter. And if an antimatter galaxy were to run into a matter galaxy, then they both would be annihilated in some stupendous flash of light and power.
As strange as it is, scientists have learned how to create minute quantities of antimatter in laboratory accelerators for medical purposes. Particles of antimatter from decaying radioactive material are injected into the body to create PET scans of the brain.
Many people don't realize that when they go to the hospital and have a PET scan, they're actually being injected with a source of antimatter. The P in PET corresponds to positrons. Positrons are anti-electrons.
And it goes to some part of the body that they're trying to figure out what's going on, and then when the positron's emitted, finds an electron very quickly, annihilates with it, and the gamma rays come out of the body and are detected.
It concentrates in the parts of the brain where there's mental activity, and then we can detect the emission of positron radiation. So this allows brain scans to give us gorgeous photographs of the thinking brain, made possible by antimatter.
While antimatter has helped to unlock the secrets of the human brain has yet to unlock all the secrets of antimatter.
We do not know why the universe is made of matter now, but we are making progress towards answering that question, little steps at a time.
Like many mysteries in our ever-changing universe, the truth about antimatter may remain for now in the realm of the unexplained. Mars and mystery have always gone hand in hand. But the most intriguing mystery of the Red Planet has nothing to do with alien invaders. Scientific evidence suggests that Mars was once a more Earth-like planet, with one of the key elements to support life: water.
Water existed in abundance on Mars.
We find the evidence of old flows. We see a little tiny bit of water vapor in the atmosphere.
There are even features on Mars that look like old river valleys and floodplains.
It was once a tropical planet with oceans and seas, but all that water disappeared.
How could all the water on Mars have simply vanished? And why did it disappear? These are mysteries that scientists are struggling to solve. Geologic evidence gathered by the Mars rovers and orbiters suggest that 3.5 billion years ago, Mars' watery surface changed dramatically. The once temperate planet became a cold, dry place, and the water vanished. But figuring out when the water disappeared doesn't tell you where it went or why.
The water on Mars was lost a very, very, very long time ago. And I'm talking billions of years. And the clues that would lead you to know where that water went are long gone.
A series of events on Mars appears to have drastically changed the watery landscape. Mars endured an intense period of volcanism that spewed lava across the surface. When it finally ended, the planet's molten iron core solidified. This may have been what caused Mars to lose its magnetic field and protective ozone layer.
This left the atmosphere vulnerable to the solar wind from our sun, which is quite powerful.
Solar winds pummeled the planet for millions of years, stripping any remaining atmosphere. Now, water vapor that once fell as snow or rain escaped the planet's small gravitational field.
The water is brought up into the atmosphere as water vapor, and it's bombarded by ultraviolet radiation, which can split water, which is H2O, into hydrogen and oxygen. And the hydrogen, being the lightest gas known, floats up to the top of the atmosphere and can get swept away by the solar winds.
Another theory for the loss of Mars' water involves a threat from outside the planet. There's evidence that in the early years of the solar system, Mars resided in a deadly flight path.
There's one cluster about 3.9 billion years ago called the Great Bombardment that really must have peppered that planet with many, many impacts. And that kind of an event would have actually thrown material and atmosphere right off of the planet and outside of the gravitational field. Let's imagine that we have an asteroid here, and this asteroid is really the size of a mountain. And imagine this is tumbling through space at very high speed. And we're talking tens of thousands of miles per hour. If we come zipping in at high speed, splat. It's lost to space. Much of it will sink in, some will become atmospheric gases sputtered away to space, some will be lost.
Other answers to the mystery of Mars' disappearing water may be hidden deep inside the red planet. Some of the water combined with carbon dioxide to form polar ice caps up to 2 miles deep and a permafrost that covers much of the surface. But there's evidence that beneath the ice, liquid water still flows.
Much of the water on Mars has gone underground, and some of it certainly has migrated down to a depth where it's warm enough for it to exist as liquid water. And then when it gets colder, it's going to be frozen into a cryosphere, if you like, an ice part of the subsurface. And then near the surface is going to dry out as the water can move through the soil and go into the atmosphere.
University of Arizona scientist Peter Smith is eager to solve the mystery of Mars' disappearing water.
Okay, I'm digging a little trench here to show you what happens if you get below the absolute hyper-arid surface and go down just a foot or so, because this is similar to what we're going to be doing on Mars.
Smith is the principal investigator for NASA's Phoenix Mars mission. It's a robotic probe with one simple objective: land on Mars and follow the water.
What happened to that water? Could have frozen into underground ice or even aquifers of liquid water. These are something we're looking for today, using radio and radar to penetrate through the surface and try and locate these reservoirs of water.
Smith believes that Arizona's Wilcox Playa reflects what scientists will find when Phoenix finally scratches the red Martian surface.
Even though the surface is parched and salty and dry, just within 6 inches of the surface is a very wet clay, like a reservoir of water, and there's a whole ecosystem of life that's living in these wet soils and these clays. When it rains, it comes to the surface. And in fact, you see little pools where actually brine shrimp that are locked into these soils. We wonder if we get down under the surface in the right place on Mars, and that is the permafrost region, can we find the same sort of ecosystem around the ice, melting over time as climate changes, that's habitable for some sort of Martian life forms?
Some believe that life on Earth originated on Mars and that its strange transformation foretells our destiny. If that's true, finding Mars water may lead us back to our cosmic beginnings and into the future. When it comes to the universe, what we know is surpassed only by what we have yet to learn. And of all the unexplained mysteries, one remains the greatest of all. Did anything come before the Big Bang? Or was that event truly the beginning of everything? And if it was, what was the spark that lit it?
This is the greatest mystery in all of science. What started creation itself? Big Bang Theory has this tremendous hole in it. We are clueless. We are clueless as to what set the Big Bang into motion.
The Big Bang is the cosmological model for the birth of our universe, 13.7 billion years ago. Everything in our universe can be traced back to that moment.
There seems to be this mysterious point at the beginning, and we call that the singularity. But even though it's mysterious and has many open questions associated with it, it still makes a good starting point for our timeline.
But our scientific instruments are blind and deaf to the period before the Big Bang, if such a period existed at all. The singularity is like a horizon that we can never see beyond.
Because in the creation, time was created along with space and along with matter. And the Big Bang is just that sort of event. And therefore, it's impossible to know what happened before the creation event.
Nevertheless, scientific speculation as to what happened before the Big Bang is something that intrigues the greatest minds in astrophysics. Some theorists believe that our universe experiences Big Bangs at regular intervals. This cyclic model proposes that every trillion years there's a Big Bang, after which the universe expands before again collapsing, setting the stage for another Big Bang.
There's interesting ways that can connect with the story of a previous universe. The end of one universe can bring the beginning of another.
Maybe there never was a start, that it's somehow been ongoing from an earlier moment and never had a creator at all.
But we might be closer to an explanation of the pre-Big Bang than we know. The cosmic reverberations from the Big Bang that still echo through the universe may actually hold the answer to the moment before the singularity.
Turns out these standing waves are key to how we understand the universe today. Inflation gives the universe one big hit at the beginning, just like I'm hitting the pot right here. It forms the standing waves, and we can look for those symmetrical patterns in the cosmic radiation today. So we send our satellites out, we observe the radiation, the symmetrical standing waves.
A new wave of detectors, gravity wave detectors, will be launched into outer space in the next decade. Connected by laser beams, any shock wave from the instant of creation will jiggle these laser beams and will be able to then record the vibrations left over from the Big Bang itself. That's why I'm confident that we'll be able to probe not just the Big Bang itself, but even the pre-Big Bang era in the coming decades.
The lasers will also detect sources of inflationary energy,